As we begin chapter 6, we are going to start talking about systems of equations. And this is a new vocabulary word. We have been graphing equations and solving equations, but a system of equations simply means that there's two equations, not just one, but there's two equations in one problem with the same variables. So usually x and y, just like we've been dealing with, except a system means that there's two equations in one problem. And if you were to graph the two equations, you would see that the lines that you graphed most of the time will cross. That's called the solution to that system. It's where the two lines intersect. Algebraically, and we'll get into all these, you'll see these as we work through these problems. I'll reiterate these vocabulary words and use them over and over again so you'll get used to them. To find the solution to a system algebraically, it's the ordered pair that makes both equations true if you were to plug those numbers in. So if you were to plug an x and a y number in for x and y into the two equations, it's the ordered pair that makes both equations true. So again, this will make more sense as we go along. So types of solutions. If two lines intersect, so if I drew a graph here, and I drew a line here, and then I drew a line here, these two lines would intersect. That point of intersection, that's the solution. And for this situation, there would be one solution because they only intersect in one place. Okay, so intersecting lines only have one solution. And that solution would be that ordered pair where they cross at. Now, what happens if two lines are parallel? Remember, if two lines are parallel, that simply means that they never cross. So if two lines are parallel and they never cross, and the place where they're supposed to cross is the solution, if two lines are parallel, then we would say that there's no solution. And one way to notate that is by this symbol here, 0 with the line through it. It means that there's no solution. Well, what happens if you graph them and they were the same line? So if you graphed a line and that line went like that right there, and then you came back and you graphed another line, and it happened to be the exact same line, so that when you graphed it, the lines would fall on top of each other. Well, if you graph two lines and they end up being the same line, if the solution is the point where they cross at, or another way to say it, the point that they share, and these lines share every point, then you would say that there's infinitely many solutions. Or we could use the infinity sign there. So we're going to learn three different methods to solve systems of equations. And the first method is by graphing. So step number one, if you're going to graph, kind of like these situations here, then first make sure the equations are in slope-intercept form. Okay? Make sure the equations are y equals mx plus b. And if they're not, then put them in y equals mx plus b form. Okay? Then you're going to graph both lines or both equations on the same graph. And then step 3 is look and see where they cross at. Determine where they cross at. And that is your solution, is where the lines cross. So a system of equations, two equations with the same variables. Graphically, if we're trying to find the solution on a graph, we want to see where the two lines intersect. If the two lines intersect, then there's one solution, and it's that ordered pair wherever they cross at. If the two lines are parallel and they do not intersect, then there is no solution. If they are the same line and they share every point, then there's infinitely solutions. To solve systems by graphing, make sure they're in slope-intercept form, graph both lines on the same graph, and then determine where they cross at. So let's look at a couple of examples. So if I was graphing this one, y equals x minus 8, that is in slope-intercept form. So my m number is 1 and my b number is negative 8. So I'm going to begin at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And then from there, I'm going to go up 1 and over 1. And remember, this is a time where you may need to continue the line. You may need to keep putting dots. I'm just going up 1 and over 1, up 1 and over 1. And I'm going to continue this for about the length of the graph probably. And instead of going up 1 and over 1, I can go down 1 and left 1. And I'll still get this line here. And then my line will look just like that. Now for the second equation, y equals negative 2x plus 1. My m number is negative 2 over 1, and my b number is 1. So I'm going to begin at 1, and then from there I'm going to rise negative 2 and go right 1. And I'm going to keep doing this until my lines intersect. And they cross right here at this ordered pair. And this ordered pair is in the form of x and y, remember? So 1, 2, 3, and then 1, 2, 3, 4, negative 5 because I went down. So at 3, negative 5 would be the solution. The point that they share would be 3, negative 5. Let's look at another one. Y equals 1/2 x plus 9. I'm going to begin at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I need to go up 1 and over 2. This is a situation where I'm definitely going to need to go the other way. So instead of going up 1 and right 2, I'm going to go down 1 and left 2. Down 1 and left 2. Down 1 and left 2. And I get these points here that line up. Okay, for the other one, I'm going to begin at 6. And then my slope is negative 1 over 1. So down 1, right 1. Down 1, right 1. Or I can go up 1 and back 1, up 1 and back 1, and I can see that it's going to cross here at this ordered pair here. So this ordered pair here would be negative 2. 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, 8. That's the solution to that system. Okay, now, if they are not in slope-intercept form, you need to fix it. Let's look at this number 5 here. For this first one, x plus 3y equals negative 15. It's not in slope-intercept form because y is not by itself. So I'm going to take away the x from both sides. And when I take away x here, I can't combine those. I'm going to put the x first, negative x, and then minus 15. And then divide by 3. And now I have y by itself. Remember, divide everything by 3. To get y by itself, divide here, divide here, divide here. Well, this is negative 1 over 3, which will not reduce, but that's okay. That's going to be my slope. So I need it to be a fraction anyways. And negative 15 divided by 3 is negative 5. So I can graph this one. I'm going to begin now at negative 5. And then rise negative 1 and run positive 3. And I can go the other way. Okay, and I can connect these. Now for the other equation, this is one of those special cases. What's missing? The x, which means that the line I draw needs to cross over the y-axis. Well, a line that crosses over the y-axis is going to be horizontal, and it's going to cross the y-axis at -7. So right there. So I can see that they're going to cross, these two lines will cross right here. So this ordered pair is 1, 2, 3, 4, 5, 6. So +6, and then 1, 2, 3, 4, 5, 6, 7. -7. And that would be the solution. So that's how we solve a system of equations by graphing. You graph one, you graph the other on the same line, look to see where they cross at, and that's going to be your intersection point. Now remember, if they cross once, there's going to be one solution. If they don't cross at all, if they're parallel, then there's no solution. And sometimes you have to find points on one side of the line and also points on the other side of the line to figure out when they cross. Okay? And then if they happen to be the exact same line, then there's infinite solutions. Good luck.